So let's start our discussion. So welcome back, all of you, for our R programming sessions. So like always, we are going to discuss some concepts in R programming language today. And then we'll try to apply those concepts in our R programming language. We'll do that. And then I've shared some files with you. So whatever concepts we have discussed so far, in all our previous sessions, whatever codes I have used, whatever data sets I have used, I have shared them with my team members here at ExcelR, and they will be very soon sharing those documents with you. So you can listen to our recordings and you can practice using those recordings on our R programming files. And you can use all the data sets what we have used, and you can try and develop your R programming skills. So this is what we can do. Now, in the last class, we were discussing some concepts in visualizations. So one commonly used visualization, what we have seen is called as a histogram first. So how did we do this? Let us try to recreate our histogram so that we can refresh some of the concepts and then we can proceed forward. So let us create a new R file and then let us import our data set. So this was our data set imported. So we have three columns here. We have seen data serial number, work experience, and GMAT. And now let us try to create our histogram. So it's very straightforward. You can say hist and then open brackets. You can say MBA.GMAT first. So it has created this histogram. So histogram, we have understood that. It will explain you about the frequency distribution of our data. So it is a univariate distribution because here we are focusing only on one variable, which is GMAT plus. So on x-axis you are going to have your GMAT, and on your y-axis you are going to have your frequency. So this is what you're going to have on your histogram. Now, we can understand that most of our students are scoring in the interval of 700. Very few students are scoring in these intervals for us. So in order to bring more clarity to our histogram, we can break the histogram into specified intervals of data first. You can see breaks is equal to, I want to break my histogram at these levels. So I want to break my histogram in these intervals. So this is 600, 625, 650, 675, 725, 750, 775. So most of our students are scoring in this interval class, 700 to 725. Now, let me add some color. If I say color is equal to, if I say blue or green, it is going to change the color of your history. So this is how you can add some color to your visualizations and you can create different types of charts. Now, apart from color, what more you can do is, we can say labels Okay, I think my screen should be visible for you. Just check once if you are able to see my screen. So I'm saying labels is equal to true. So now we are getting a different result for us. Labels is equal to true. But I was expecting some other result. Let us try to fix that. You have to give labels is equal to. It should work. Just 1 second. Yeah, I got it. What is the mistake we are doing? We are giving that in quotation marks. So we should not give in quotation marks. That is a mistake what we are doing. So labels is equal to true if you say, you are going to get the values. So all these values you are able to get. So 282 students are there in our data set who have scored between 700 to 725. Then you have 600, you have 12 students who have scored in the interval of 600 to 625 plus. Now you have 2 students who have scored in the interval of 775 to 800. So you can understand how many observations are present in each interval. How many observations are present in each interval first. This you can understand from your histogram. And we can also see name is equal to, I can give some name here. I can say histogram. So you see now, the title of this histogram has changed. It has become histogram of Gmail. So like this, you can modify, you can make some changes, and you can create these kind of visualizations. So this is the first visualization what we have seen. Now let us discuss another visualization, which is called as box plot first. Box plot. So first let us try to create this. So I can say box plot, all small letters, box plot, MBA dollar, Gmail, plus control. So this visualization, what you are seeing on the right hand side, is called as box plot first. It is going to give us information about 5 points. What are those 5 points? What is your upper limit? What is your lower limit? What is your median? What is your quartile 1? What is your quartile 3? So it is going to give us about these 5 points information. And it is also going to tell us about, are there any outliers in our data set? What is the definition of outlier? Any observation which is distinctly different from all the other observations that we have in our data set. Any observation which is distinctly different from all the other observations which are present in our data set. You are going to call those kind of observations as outliers. So box plot is a visualization which can detect these kind of outliers. So this is the purpose of box plot. Now, let us imagine you are watching a movie. So interval is the middle point of the movie. It is called as median. Now, middle point of first half of your movie is called as first quartile. Middle point of second half of your movie is called as third quartile. And this region is called as your box. The shaded region is called as our box. So this box is going to contain 50% of the observations present in our data set. So you can call this region as box, or you can call this region as interquartile range, IQR. What is the formula of this interquartile range? It is Q3 minus Q1. It is the difference between your two quartiles, Q3 and Q1 cars. Now suppose somebody gives you a question, find out what are the values. What is Q1 value? What is Q2 value? What is Q3 value? So Q1 is known as quartile 1 or lower quartile. Q3 is known as quartile 3 or upper quartile. Then Q2 is also called as median phase. So how can we find out what are our Q1, Q2, Q3 values? Simply what you can do is, simply you can say summary. So this is our upper limit. This is our median or quartile 2. This is our upper quartile. This is our lower quartile. These are our outliers. So this is the information what we have. This is our lower limit. So now, when you give summary function, you are able to get what is the median value. Median value is 710 plus. What is the first quartile value? So first quartile value is 690 plus. What is the third quartile value? Third quartile value is 730. So we are able to find out simply by using our summary function. What is Q1? 690. What is Q3? 730. What is Q2? It is 710 plus. Now, I told you interquartile range. What is the formula? Q3 minus Q1. So interquartile range value is 730 minus 690. It is 40. Where can I use this interquartile range? That is the question. This interquartile range can be used to calculate your upper limit values and your lower limit values. You can calculate these points. What is your lower limit value? What is your upper limit value? So write down our formulas. Lower limit formula is Q1 minus 1.5 times IQR. Upper limit formula is Q3 plus 1.5 times IQR. This is what we have to write down. These are the formulas. So how to calculate our lower limit now? Lower limit is Q1, 690 minus 1.5 times IQR. IQR is what? 40. So 690 minus 60 is 630. So lower limit is 630. So what is the meaning now? Any observation which is less than 630 in our data set, we are going to consider those observations as outliers. So if you have any observation which is less than 630 for us, you are going to call that as outliers. So now observe what we are going to do. If you want to find out what are your outliers in our GMAT column present in our MBA dataset, what is that you are going to do? You have to write box plot, okay, in brackets, MBA dollar GMAT, and you are going to say dollar out. This is what you have to say. So what is it we can understand from here? These are all our outliers. So among these values, what is happening? There are three values which are continuously repeated. What are those values? 600 is repeating, 610 is repeating, 620 is repeating. So effectively, your conclusion should be there are three values in my GMAT column which I have to consider them as outliers first. So what are these values? You have to consider 600, 610 and 620. So any observation which is less than 630, that is 600, 610 and 620, they are all considered as outliers first. They are all our outliers. Now, what is this indicating? That means there could be a possibility where I can have multiple students who can get 600 in their GMAT examination. I can have multiple students who can get 610 in their examination. I can have multiple students who can get 620 in their examination. So these are all those students. These are all my outlier students who are getting these scores in their GMAT examination. So anybody who's going to get less than 630 for us, you can conclude that that person or that score will be considered as outlier for us. So outlier means any observation which is distinctly different from all the other observations that we have in our data set. So it is not always necessary that you have outliers only below your lower limit. You can have outliers above your upper limit also. It is possible for you to have the outliers above your upper limit. So let us calculate our upper limit. Upper limit is Q3. plus 1.5 times IQR 40. What is Q3 value? 730 plus 60. So there is not even a single observation in our data set which is beyond this value of 790. So therefore, we don't see any outliers here. So box plot is a distribution which can help us detect our outliers, spot our outliers. So this is what we have to understand. So this is the another most commonly used visualization for us. It is called as box plot. So we can create on different columns. You can say box plot, and I can say MBA dollar work experience. So now you see all these observations, all of them are your outliers. So all these observations are our outliers. So in this manner, box plot can be used to spot our outliers. So this is another visualization, what you can create. Now, whenever you want to explore any function, you can say question mark and give box plot. So it is going to tell you how you can create your box plot. So you can read through all these things and you can try and recreate. So whenever you are in doubt, you can automatically use this. It is like your help function. Question mark and box plot first. Now, apart from this, what are the other visualizations what we can create? So let us try to understand one by one. Let us try to create a simple bar plot first. So how do we create this bar plot? So ready-made function is there, bar plot. And then you can say what is the data you want to apply on. Do you want the axis or not in your bar plot? What should be the y-axis label? What should be the names for each and every bar? We can decide all these things. So let us create one bar plot and then we can understand. So this is my data. I'm creating some random data here. 15, 24, 38, 54. So I've created my data here. And then now I'm saying apply this bar plot function on my data what we have created. So press Ctrl Enter. So now you see, you have a bar plot here. So these are our values 15, 24, 38, and 54 for us. And the names of my bars, I have said, give the names of my bars as 1, 2, 3, 4. So I have my names of my bars as 1, as 2, as 3, as 4. So these are the names of your bars. So if you want to explore more bar plots, you can always keep question mark and you can say bar plots. So when you say bar plot here, so if you scroll down, let us take one simple example. So you have this example. So I've just copy paste that. And now let us try to understand. So I'm saying bar plot and I'm saying create a bar plot between gross national product and year. Year should be on x-axis. Gross national product should be on y-axis. And data is coming from Longley data set. This is what we are saying. Now I'm going to press Control Enter. So why are we not able to see this bar plot here? That is the question. Okay, I think there is some challenge with your R Studio. That is what is happening. Normally it should get displayed here. Okay. So let us try to fix this. Yeah. So I just executed the code here. So you can run the code. So far we have seen how to run your commands in the first screen. You can also run your commands in the second screen also. So this is on the right hand side, you are getting your bar plot for us. So you have your year on your x-axis. You have your gross national product on your y-axis. So this is the information what you have. Okay. And you can see gross national product has been increased. So if gross national product is increasing, then you can expect the country is doing well. It is an economic indicator for us. So now, if you want to explore this data set, what you can do? This is a ready-made data set inside our R Studio. I can say view. So this is my data set. So my data set is having columns GNP deflator, GNP, unemployed, armed forces, population, year, employed. Okay. So this is one simple bar plot we have created. Now there is another example. What is it we're trying to do here? We are saying combine these two columns and give me what is the employed proportion, what is the unemployed proportion for every year from your long lead data set. This is what I'm saying. Now observe how it is going to look. So now what you have done is your year is on x-axis first. So year is on x-axis for us, and then you have your employed and unemployed. So you can study how it is changing. So this is an example of another bar chart for us. So this is called as a stacked bar chart. So this is how you can take the examples always from your R documentation, and definitely you can try out these examples. You can experiment with them and you can find out what is happening in your data. It is always a good exercise for us. Now, if you want to study about this data set, what is it you can do? Simply give question mark, and if you say long D, then it is giving you this data. Economic regression data. So it is a data frame with 7 economical variables, starting from year 1947 to 1962. So you can explore about this data set. Where is the source? What are the references? And again, some examples are there. That is it. So this is how you can create your bar plots. One bar plot we have created on our own data. Our own small custom data we have used. Okay. And then we have created our bar plot. And then later on, we have simply used the examples present in our R documentation. And then we have worked out on our data sets. So that is how you have to experiment. You have to try out different examples. And you'll be in a position to understand the concept. Now, let us try out our pie chart. So pie chart also, a ready-made function is there. You can use pie. And then I'm saying I want to apply my pie on my data, what we have created. And then I'm saying label my different portions of my pie with these names 1, 2, 3, 4, and radius of my pie chart should be 1. So these are some of the things I'm mentioning. So what is the first thing you have to do? You have to execute these commands, names, and then execute your py function. So now you see it is a small pie chart indicating our values 1, 2, 3, 4 for us. So these are representing 15, this is 24, this is 38, this is 54 for us. So this is a simple example for our pie chart. So pie chart also, if you want to explore, it is the same logic again. Give question mark, give pie. So it is going to give us some results. Okay, graphics.pie charts, look for this option, click on that, and now you see it has given you the documentation. Okay, let's try one example. So I'm saying pie.sales. Okay, these are my sales. I've just created a numeric vector for us. And then names for my pies: blueberry, cherry, apple, Boston cream, other, and vanilla cream. Okay. Now you can see pie on this pie.sales. So now you have your pie chart. So this is a simple pie chart. What we have created. So in this example, we are applying all the concepts what we have seen before. So what are those concepts? We have used our names function. We have used. Okay, you know how to assign your names to your numeric vector. So this is blueberry, and this is cherry for us. This is apple, Boston cream, then other, and vanilla. So which flavor is making more sales for us? Cherry. Cherry sales are more. Okay, which flavor of pie you are able to sell more? Cherry. Other flavor you are not able to sell. So this is what I have. Pie. Pie is a function. What we are using. Now, go to your help. Now we are mentioning some predefined colors. Okay, we are mentioning those. So copy paste this piece of code and then press Control Enter. So now we are able to change the colors in your pie. So in this manner, we can experiment. So all that we are doing is we are simply going to the help function, taking some examples, and with the examples, we are trying to learn how to write small programs, small commands in R. So this is what we do. Simple visualizations. So histogram we have seen, then box plots we have discussed, and then we have seen our bar plots we have seen, and pie charts. All these visualizations can be used for exploring our data, for getting more information from our data set. So this is what we have to understand. So similarly, we can create some more visualizations like scatter plots. We can create some more visualizations like scatter plots. So for that, let us use another data set. We'll try to apply these concepts on another data set. So what is the data set that we are going to use? We are going to use one data set called as air quality. So this air quality data set is present in our package called as data sets first. So it is present in a package called as data sets. So we can say data sets and 4 colons you have to give like this. 4 colons. And you have to give the name of your data set. What is this name? We are giving us air quality data set first. So that is what we are doing. So load our data set first. So we have loaded our data set. So all the contents of our data set we have stored in a variable called air quality first. All the contents we have stored in. Now if you say view air quality, then it is going to give you the details of your data set. So you have ozone column, you have solar radiation column, you have wind column, temperature column, month column, day column. So all these columns are there, and this data set is called as air quality. So if you want to know more about the data set, then you can simply give question mark air quality. So this data set is talking about New York air quality measurements. So this data set is talking about New York air quality measurements first. So this is the information you should have before you start working on your data set. So basic idea you should have. What is this data set all about? How many observations are there? How many variables are there? Ozone column, solar radiation, wind column, temperature, month column. Okay, what are the details? Daily readings of air quality values taken from May 1st, 1973 to September 30th, 1973. Ozone, mean ozone in parts per billion from 1300 to 1500 hours at Roosevelt Island. So it is giving us specifications, how they are measured. Now, what is that we are going to do is, we are going to create one small visualization. What is that is? It is called as a scatter plot first. Right now, PLOT plot. And then you are going to say air quality, dollar, temperature, press control. So this is a scatter plot visualization. So it is a scatter plot visualization. So it is giving us an information across all 153 observations. How is my temperature changing in New York City? And this information we are able to get. How is my temperature changing? Now, instead of temperature, you can also have a scatter plot for a different column. I can say plot dollar wind. So this is the scatter plot for my wind. So now you can understand how is the wind capacity changing in New York City. What is the average wind speed in New York City? I can get an idea from my scatter plot. And these circles, what you are seeing, they are all called as points. Okay. These circles, what you are seeing here, they are all called as points. So now observe what we are going to do. I'm going to say plot quality dollar wind, comma, type is equal to L. Observe what is going to happen. So from my points, I am able to convert this into a line chart first, into lines. So just by giving type is equal to L. L stands for lines. Now if I say type is equal to P, then it is going to give me the old visualization, what we have created, that is points. It is going to give us back the old scatter plot. So try change this to P here, press Control Enter. So now you see it has gone back. It has gone back to points first. So you can switch from lines to points. You can always do this, switching from lines to points. Now, if you change it to B, then you see what is happening. It is a combination of both. You are able to see lines and also you are able to see points. So B means both. I want both my lines and I want both my points. So same scatter plot only we are creating, but all these are different variants in our scatter plot. So different variants in the same scatter plot. So again, if you want to explore further, you are simply going to say question mark and 2. We have our scatter plot. So again, you can change these values, P. And you can experiment with. Type is equal to P. So you have P for points, you have L for lines, B for both points. You can also try out C. So you see, I'm trying out something else, C. And then I can also try out O. This is O for us. So you can try out S and capital S. All these things you can try out. Yes. So in this manner, we can explore. So we'll take a break here for 10 minutes. And then we come back and we'll continue our discussion with scatter plots. So take a break.
Guys, 2 minutes. We will resume the session within 2 minutes.
So let us continue. Yeah. So we were discussing our scatter plot. Now, what we are going to do is, instead of only using a single variable, so instead of working with a single variable for us, like wind, let us work with two variables. So what is that we are going to do? Plot air quality $wind, air quality $temperature. Okay. And then type is equal to points. So now we are getting some error. So spelling of air quality is wrong. Okay. So let us go back and check. So now if you see, we have created a scatter plot between our variable wind and our variable temperature. So wind variable is there on your x-axis and temperature variable is there on your y-axis. So what is that we can understand? We can understand the relationship between our variables. So we can understand what will happen if one variable changes. what kind of impact it is going to have on the second variable. So from this visualization, you can understand that wind and temperature, they are inversely proportional for us. So we can clearly find out this relationship. That if my wind is increasing, if you observe, my temperature is decreasing. So this relationship is important for us. This relationship between our variables is important because you can understand what is the pattern present in your data. So wind is inversely proportional to temperature. So this is the understanding what we are able to get from this scatter plot. Now, you can also say that there is a negative linear relationship or association between my two variables. What are they? Wind and temperature first. There is a negative linear relationship between two variables, wind and temperature. Now, let us try to take two more variables. We'll try to understand what is the association. So we are copying the same piece of code, pasting it here. And now, instead of wind, I'm taking ozone. So now if you observe, what is the relationship between temperature and ozone? The relationship is they are directly proportional. As my ozone level concentrations are increasing, that means temperatures are also increasing first. So these are directly proportional to each other. So this relationship is important. We have to understand this relationship, and this is the pattern. So now I can represent this relationship in the form of a simple straight line equation. Y is equal to mx plus c. So what is my x? My x is my ozone. What is my y? My y is my temperature. So if I know what is the ozone level concentration, I can estimate what could be the temperature in New York City. So that is how I can use this piece of information. So this is called as creating your scatter plots. And based on scatter plots, we are trying to understand what is the relationship between our two variables in our data set. So we have seen wind and temperature, we have seen ozone and temperature, we have seen. Now like this, if I want to see for all the other possible combinations of my variables, then what is that I can do? I can simply say plot here. I can say plot and I can say airport. Okay. Now press Control Enter. So you see this. It is giving us the scatter plots for all possible combinations of your variables which are present in your data set first. For all possible combination of variables, it is giving us. So if you want to understand the relationship between wind and temperature, you can study from here. Just now we have separately created this visualization. They are inversely proportional. Now, what about ozone and temperature? So you can understand that they are directly proportional to ozone and temperature first. Ozone and temperature. So just now we have separately created this. So if you look at this matrix here, what we are having, bottom half of your triangle is exactly same like your top half of your triangle. So either you can focus on this portion of your scatter plots, or you can focus on the other portion of your scatter plots. So it is up to your choice. Both of them are mirror images to each other. So both of them are same. So this is what we have to understand. Now if I ask you what is the relationship between ozone and wind. So they are negatively associated. They are inversely proportional. So this understanding the relationship between our variables is very important for us. We are trying to understand the relationship between our different variables. So what did I just say now? You can either focus on this portion of your triangle. This is one triangle for us. Or you can focus on this portion of your triangle. This is another triangle for us. So this bottom triangle and this top triangle are mirror images to each other. So they are same. So what we are doing? We are focusing on this portion of your triangle. Now from this triangle, you are able to understand what is the relationship between your different variables. Temperature and ozone. Ozone and solar radiation. Like this. Whether they are directly proportional or they are inversely proportional for us. So this concept is important for us because if you want to develop a relationship, if you want to develop an equation, then this scatter plot information is important for us. So now it is that time of the day, 8:30, where attendance link will be circulated. So please try to fill in your attendance sheet. And then always come back and you can attend our sessions. Yeah, good job. So attendance sheet is being circulated. It is there in your chat window. So try to fill in this attendance sheet and then you can always come back. Yeah, Saturday there was no session, Afzal. So there is no need to worry. So only we are going to have sessions from Monday to Friday. So try to fill in your attendance form today. Yeah. On Friday, if you have missed, no problem. What you can do is just reach out to the ExcelR team who is here, let them know, and they are going to consider your attendance. Now, so far we have seen some visualization started off from histograms, then box plots, bar plots we have discussed, and then we have seen our pie charts, and we have seen our scatter plots, different variants of scatter plots. And now using the scatter plots, we are able to find out what is the relationship between our variables. So all these things we are able to do. Now, I'll show you something else. What is that is? Same bar plot, the concept what we have discussed. If you try to create it on this data set, how can you create it? So I'm saying bar plot, create it on my data. What is my data? It is my ozone column. And then my title is ozone concentration in air. This is my title. The y-axis label is ozone levels. Color is blue. Horizontal is equal to false. That means I want a vertical bar plot. That is what we are trying to do. And I'm saying axis is equal to so this is what I'm saying. So try to create this. Now this is our bar plot. So we have seen how to use a bar plot on this data set. So title is ozone concentration in air. This is your axis. And your color is equal to blue. You are saying horizontal is equal to false. So it is giving you a vertical bar plot for us. So now why are we seeing these gaps here? These are all null values. We have null values in our data set. So if you go back and if you check, if you say view air quality, you see you have null values. You have null values in your ozone column. Now, how many null values are there? Summary, air quality, dollar, ozone. So you have total 37 null values. So 37 null values are in our ozone. So now, if you want to find out what is the average ozone level concentration, we are able to anyways get it from here. But what if you want to use your mean function? How can you apply? If you apply mean air quality dollar ozone, watch what is going to happen. It is not giving us any result. So it is not giving us any result because you are having null values in your ozone column. So how do you overcome this now? I can simply say comma NA dot RM is equal to, I give 2. That means I'm saying remove my null values. And then give me what is the mean value in my ozone column. So now it is going to give us this. So we are getting the mean value. So NA.RM, whenever you are having your null values in your data set. So this is how you are going to overcome that problem. Now if you say median, quality dollar ozone, so this is your median. So same functions in this manner you have to apply. There is no change. The only thing we are using a small function which can help us how to remove our null values and then calculate based on our requirement. That is the idea. So this is a small concept for us. So this is a simple bar plot that we have created here. It is having some null values. Now, we have created just a single box plots we have created so far. This box plot, just now we have seen in the last 1 hour what we have discussed. So box plot, air quality $wind, and main title should be box plot. So you have your outliers here. So now what you can do, you can also create multiple box plots at once. So how you can do that? I'm saying box plot, air quality. And now observe, I'm saying comma, 1:4. This is what I'm saying. So then what is going to happen is it is going to create box plots on column 1, column 2, column 3, column 4. And then I'm saying main is equal to multiple box plots. Title is multiple for us. So try this out. So you have all your multiple box plots for ozone, solar radiation, wind, temperature. We are able to create multiple box plots. So you can always play around with that code. So basic function is box plot. There is no change. But we are simply trying to work around, work on different data sets, trying to apply the same concept so that we become familiar with all these concepts and try to create these different types of visualizations. Histograms, box plots, bar plots. Bar plots also we have seen so many varieties. Now, if you simply change horizontal is equal to true, if you make this, then it is going to give you a horizontal box plot. So far we have seen vertical box plot, but now this is slight changes. It is a horizontal box plot. So that is the idea. So same function only, we are just using it in different ways. Same visualizations only we are trying to create in different ways for us, for better understanding of our data. For better exploration of our data. So that is the logic. So like this, we can create your different types of plots we can create. For example, we can create something called as density plot. So it is saying it does not exist here. Give density. So kernel density estimation. Okay, let us try this small thing. Okay. So this is the code what we are writing. So we have something called as density here. Faithful dollar eruptions. So let us first create this. We'll see what it is going to give us. So this is our density plot. So what is that we are seeing? We are seeing there is a there is a data set called as faithful. So let us go here. View faithful first. So this is our data set. Eruptions and weightings. 2 columns are there. Now let us try to understand this data set better. What is this data set? Faithful. So waiting time between eruptions and the duration of the eruptions for the old faithful geyser. So we are talking about geyser data here. And data which has been collected between eruptions and duration. What is the waiting time? So now we want to create on this data. Now we have simply used this function called as density. So density is going to create our density plot. And then let us try to explore this now. So we have density. And then we have all these parameters that we can use. We have weights. We have na.rm. So all these different parameters. Okay. X means what is the data. Okay. Then BW means bandwidth. And then we have just picked one, a small example. Okay. And now if you see, let us try something like this. Plot D type is equal to n. So now you see, things have changed for us. So n has got some significance. So how do you find out what is the significance of this? Again, go here and then study this. A number of equally spaced points, that is n. So now, if there is not much information here, then what you are going to do? Go to Google. You can say density plot type and you can explore. So you can read through. Okay. So you can get some idea about how to plot. So what is the density plot? What is the density function? How are these things? All these things you can understand. So like this, different types of visualizations you can create. It depends on your choice. It depends on your analysis, what you want to do. So let's keep it plot D. And you are able to see your density. Now let me try something else. Okay, I'm going to say sepal length. Let me remove these things. So this is my density plot for my sepal length. Okay, so we have changed the data set here. I just want to create a density plot for my sepal. So there is a question here, can we do all these things in Visual Studio Code? Yes, definitely you can do. All these things you can do in your Visual Studio Code. Now same density function I can apply on some more data sets. For example, I'm going to say MBA dollar. So this is my density plot for GMAT column. So same thing what we are trying to do. We are trying to do on different data sets. So in this manner, you can create different types of visualizations. So we started off from our histograms. Histograms gives us information about frequency distribution of our data. Then box plots. These visualizations are going to help us identify your outliers. Then bar plots. When you are working on categorical data, if you want to identify your outliers, you can use bar plots. Then pie charts. We have seen multiple examples. Then later on, scatter plots. So scatter plot with single variable we have seen. Then scatter plots with two variables we have seen. And you can understand what is the relationship between our two variables with the help of your scatter plots. So that is what you can do. You can understand whether they are directly proportional or inversely proportional first. Then we have seen how to create our different types of bar plots. Horizontal bar plots we have seen. Stacked bar plots we have seen. And then how to create your multiple box plots. So all these visualizations we have seen. And then finally, we came around this density plot. So here if you see, most of my observations are concentrated here. Density is very high, around 700 in their GMAT score. So this is a dense region first. This is a sparse region first. All these are sparse regions. Opposite of density is sparse, sparsity. So these are sparse regions. These are dense regions for us. So like this, you can practice, you can apply them in your small projects and all, and you can create these visualizations, get some insights, and you can share those insights, and you can explain your findings. So all these things you can do. So creating your visualizations in R. Now there are dedicated packages also. There are exclusive packages for creating your visualizations, like ggplot2, like graphics package. So all these packages have additional visualizations. So apart from what all visualizations we have seen, you can also create so many more types of visualizations. So that also we are going to discuss in our coming sessions. So in our going forward sessions, the agenda is going to be try to learn some of these visualizations libraries, and then we'll try to discuss some basic programming concepts in R. So like loops, how do you create your own custom functions? All these concepts we'll be discussing. And then we will also discuss some more data manipulation. Like there are packages like dplyr, how you can use your filter function, how you can use your select function. So all these different types of functions are there in your dplyr library first. So all these things we are going to discuss in our coming classes. So for now, today, we have invested our time in understanding the visualization concepts. So tomorrow we'll continue in the same direction. And then again, we'll focus on your basic programming concepts. And then also some more data manipulation using R. So till then, take care. Thanks very much for your time. And stay safe. I'll see you all again tomorrow. Till then, all the best to all of you and good night.